Bismillahirrahmanirrahim. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Our paper entitled Constructed Wetland with Cyperus Alternative Use as a Sustainable Solution for Household Greywater Treatment. Let's start with the From global point of view, water pollution is becoming a serious concern. Sanitation and fresh water was one of the 17 Sustainable Development Goals declared by United States in 2015. Indonesia, in 33 provinces, most rivers were heavily polluted, monitored by the Minister of Environment and Forestry in 2016. Some researchers found that rivers flowing in and around the large cities contain 70% of organic loading originating from domestic wastewater, in which most of them are in the type of greywater. This greywater is commonly discharged into the drainage system without any treatment. As households regularly every day dispose of greywater, certainly it has become a significant contributor to water pollution. Okay, the conventional wastewater treatment plant usually covers heavy machine built with concrete and steel construction. These are not renewable material. This is the picture of one of the wastewater treatment plant in Indonesia. This system is centralized system. Of course, these are expensive and not environmentally friendly. Our country has already built 13 wastewater treatment plants. However, only service around 0.4 to 10% of Indonesian population. Okay. And usually, sanitation is the budget, low budget is usually allocated for sanitation. So sanitation has not been a primary concern. Based on this background, it seems that constructed wetland needs to be built as decentralized system. This picture is one of an example of constructed wetland in California. This wetland is for communal household. Now, what is greywater? Greywater is all wastewater come from bathroom, washing machine or washroom, and kitchen. Is separated from black water. Okay. Usually, the greywater is discharged directly to existing canal. It needs to be treated before discharging. So, what is technology? The technology suitable for developing countries is constructed wetland. These are decentralized systems, not expensive, easy to operate, and give green aesthetic view, because these wetlands use aquatic plant in the system, so that this system is environmentally friendly. In our population, the separation of gray water and black water at its source means at each household or building usually has been separated. So the gray water treatment is potentially applied in households or individual building. Okay, this stereotype of constructed wetland or man-made wetland. These are artificially engineered ecosystems which is designed and constructed to replicate natural wetland system processes under controlled conditions for treating wastewater. The basic component of this artificial wetland contains basin and then usually covered by liner so that the wastewater will not infiltrate in the ground. And then these are wetland plants, and these are media filter, this gravel, and then this is fine sand, and in this part is inlet structure and outlet structure. After treatment, the treated wastewater flow into the final disposal. Okay. Additional component can contain adjusting pipe in the outlet structure, and aeration pipes also can be installed along the wetland. Okay, our study used 2 aeration pipe. Okay. So the aim of this study was to evaluate the sustainability of an old single constructed wetland. This is after 4 years of operation, and the treated gray water compare with the performance of a new smaller one. This is the smaller one, and this is the bigger one. Thus, using the same plant Cyperus alternivus and using the same filter media that are sand and gravel. The dimension, the bigger one is 170 and 70 wide and 70 height. The small one, the length is 71 centimeter, the width is 42.5, and the height is 52.5 centimeter. This picture shows the gray water before treatment, and these are after treatment. So we can look at this, that the after treatment is so clean compared to the water before treatment. Okay, so this study is experimental research starting from setting the model, and then media filter and the plant are washed, and then we provide period of acclimatization, meaning that we provide such time for the plants to adapt to the new environment in the wetland. And then we run and taking sample, and finally laboratory testing. What is the result? Okay, in this study we only test 4 parameters that are biology, oxygen demand, total suspended solid, detergent, and dissolved oxygen. If we look at the result, This is the influent before treatment, and this is the effluent after treatment in the bigger wetland, and this is in the smaller wetland. So the three, all of them shows the result that the effective removal of the parameter load, the average efficient removal larger than 94%. Okay. BioD 94, TSS 94, detergent 97, in the bigger one, and in the smaller one almost the same. Okay, 96, 95, and 94. For increase of DO, in the bigger one, the increase almost 100%, and in the smaller one around 80%. So if we look at this result, constructed wetland is significant higher. The result is significant higher. So it can be said that this wetland can help to minimize the pollution in the water bodies. Okay, the pH and temperature, the average of pH and temperature fulfill the existing standard. If we compare the effluent with the existing requirement based on the regulation, A, regulation from the Minister of Environment and Forestry, and B is the regulation from the Minister of Health, and C is the Indonesian government of regulation for irrigation. So class 4 is the water quality for irrigation. So for BioD and TSS, the effluent in both wetland, B and C in both wetland, is far less than the maximum standard. So it's fulfill the requirement or fulfill the existing standard. For detergent is unfortunately the average effluent is still higher than the requirement or higher than the limitation based on the regulation from Minister of Health. And based on the Indonesian government regulation, no need, not required for detergent and DO if the treated wastewater for irrigation. Okay. So even the efficient removal is significant high, but the detergent is still doesn't fulfill the requirement. Okay, there's a result that is presented graphically. We can see in this graph that the effluent or outflow or the load concentration after treatment always lower than the influent. Influent is before treatment, so always lower. So yeah, this is related to the removal efficiency as I said before. Okay. If we compare between the bigger one and the smaller wetland, the results are not significantly different. in body detergent, or in TSS. Both are almost the same. Okay. In DO, increase in DO, we can see from this graph if the result in the bigger wetland is better than in the smaller wetland. I think it's reasonable because the surface area of the bigger one is larger than the smaller one. So the process of this diffusion in the surface area, okay, in the bigger wetland is larger than in the smaller one. Okay, but the point is that the artificial wetland is significant remove the pollutant tested in this study. Okay, finally, we conclude that after 4 years in operation, the constructed wetland B, the bigger dimension, still effectively remove the biody, TSS, and detergent, as well as still increases in DO concentration. And the effluent concentration after treatment in both artificial wetland systems were not significantly different. So that the treated greywater is safe to be released into water bodies and can be used or can be reused for irrigation need. It seems that the constructed wetland represent a feasible solution for household greywater treatment and subsequently minimizes full pollution in river. So, if the conventional wastewater treatment plant is very expensive, based on this study, if each household or buildings in urban area has an individual or even a communal contracted wetland, it seems we can say that it can help reduce the pollution in the rivers. Finally, this work can be further developed by utilizing other higher adsorbent to increase detergent removal and considering other significant parameters related to water quality. Well, that's our presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.